So welcome to this class. Good day, everyone. I want to wish you happy today or happy season. Okay. So we are going to proceed with logistic distribution. So the next phase of our numpy plotting of different kind of distribution, like we did uniform distribution, we did Poisson distribution, and we did a lot of normal distribution and so many others. So we are going to proceed and move to the next phase, which is logistic distribution. So what is logistic distribution? Of course, you know that it's also a distribution more like uniform or normal distribution or binomial distribution. It looks like that, but it's used in logistic kind of regression. If you remember, machine learning, you have logistic regression. So this kind of distribution can be used to analyze anything logistic regression and also growth process, more like exponential growth, all those kind of stuff. So we are going to just look at distribution. How do you use it, and how do you use numpy to plot your chart and generate values or samples? Okay, so let us proceed. So the first thing we're going to do is to import. So we're going to import our import, or you can say from numpy import what? Random. Okay, so random. Sure. Yeah, import random. So let's import matplotlib dot pyplot, please, dot pyplot as plt, please. Import what again? Cborn as what? SNS. So these are the three packages we need. Okay, so let us proceed to the next phase. So the next phase, of course, if you are familiar with my classes, you know that this is how we have been doing it. So we have random there now, so it's logistic. So it's gonna give us, just press tab, it's gonna give you options. So logistic, let me write, you can see logistic here. So there are three parameters, so I'm going to state three parameters here. Number one, three parameters expecting you. Number one, the lock. I'm going to make it a comment, the lock, that is location, or that is the mean. So that means is the mean, that is the central position actually that the curve revolve around, like the centrality of the curve is the mean, in the mean position. So you can suggest the value. Then the next thing is your scale. Like scale means like the spread, let me call it spread, or you can say deviation. So the spread away from the mean, that's what we're talking about. So we have different scale of spread, you understand? So then the next one is your size of sample size, which talk about the sample data. Okay, sample data. Okay, so these are the three things we need. So your sample data can be 2 by 3 matrix, whatever, but we are going to just make it a single a single or one-dimensional matrix. Okay, or one-dimensional array if you like. So let us look at the logistics. So the first thing is what? Your mean. So you write it like look. So you can make the central position to be 1 or 0. So let me just use 0 here. Let me use 0 here. Then the next thing is what again? We're going to have scale, please. Scale is how it spreads. So let me just put, can you scale 1 or 2? It depends. It just give you the extent of spread. Okay, so we also have the size. Let's just give 1000. 1000. A lot of much the data, the smoother the curve. So I just want to do stop something like that. So you can print it. So you can have x equals to stuff equal to the variable. So these are your logistic distribution, but we have not draw the chart. So if you print it out, you have the distribution of values across the curve that you're going to use for the curve. So the next phase is to draw a chart source. So we're going to say SNS, which is Cborn dot what SNS dot Cborn dot this plot, distribution plot, this plot, not this plot, this plot. Okay, then you put your x. Please always write this in kind. So I want it a smooth curve. I didn't want a strip like rectangular strips. I just want a smooth curve. So that's why I'm using that one. KDE Kernel density estimation. Okay, so I have stuff like this. So I can plot it with plt dot dot show. Okay, yeah, I have plt dot show. So if I'm run it now, let's see what it's going to give us. Plt dot show. Okay, so you can see, yeah, you can see now. So let's see the central position. Let's analyze. So you can see central position is what is 0. Okay, so the spread, you can see the spread. So if you make the spread to be tiny, if you make the spread to be tiny, or okay, let me change this one first. So if my location or the mean central position is 1, what's going to give me? So you'll see that this place will be 1. After 0 you have 1, so central position is going to be 1. It's shifted a little, so most times let's just leave it in 0 for now, so you can tilt this scale of spread. You can put any value you want to put, but just as you are putting it, just monitor how it reflects, how the changes reflect on the curve. Okay, so that is 1. Let me just put 1 as a scale. So I'll run it again. Yeah, so you can see what we have. So this is just logistic distribution. This is how to do it. These are the various parameters, about 3 parameters there. Your size can also be 2 by 3 matrix or single dimension, whatever. So that is it. So we're going to stop here right now. I'll move to the next distribution. Thank you.